All right, freshmen, today, 7.2, we are going to be diving into dividing monomials. Okay, so the two things that you need to be able to do by the end of this lesson is find the quotient of two monomials. Hopefully you know what a monomial is by now. And then simplify expressions containing negatives and zero exponents. So negative and zero exponents. We're going to get into some of those. So the quotient of powers. Okay, what a quotient of powers means this. If you have something like with the same base, like in this, for instance, it's a, and you have a to the mth power and a to the p power divided by a to the p power, what you end up doing is subtracting those two exponents to simplify this. Let me show you how that works. I actually don't love this example because it's too big. But let's just say I had c to the fourth power over c to the second power. Okay, what this actually means is it means c times c times c times c over c times c. And what you'll see here is that we know that, when we have fractions, if there's something that's in common with all of the pieces, that we can eliminate that thing, right? So, for instance, if I had if I had 2 over 4, that's the same thing as 2 over 2 times 2, and we could cancel one of those 2's, okay, because 2 over 2 is equal to 1, and you'd be left with a half, right? So the same thing can happen with c's here. So here we could cancel this c with this c with this c, and we're left with c squared. Okay, so what I want you to pick up from this is the rule about the quotient of powers is whenever you divide the same base with different exponents, or maybe they're the same exponents, doesn't matter, what ends up happening is you subtract the denominator from the numerator. So in this case it would be c to the 4 minus 2, which is c squared. And the reason for that is what I just showed you. Okay, so they showed you another example with r's there, right? So let's just try some of these. We only do it with like bases, by the way. So for this one here, we have x to the third y to the fourth over x squared y. This is the same thing, just so we get a good visual. You don't have to draw this out, but I want to show this to you, okay, while you're learning this. I want to give you a nice visual of what's happening. That's essentially what this means, right? X to the third, y to the fourth means that. And then on the bottom here we have x times x, and then we have that times y. So what ends up canceling here is 1x, actually 2 x's and 1 y. And what I'm left with is x times y times y times y. Or I could say this is x times y to the third power. And I could have done that without writing all this out, because I know that x to the third over x squared, I could subtract. I could say that's the same thing as x to the 3 minus 2, or x to the 1, right? And then for the y's, y to the fourth, y to the 4 minus y to the first power. Y to the 4 minus 1 is the same thing as y to the third. Okay, so I end up with x times y to the third. That's example 1a. Let's look at b together, and I kind of want you to try this one on your own. But for this one, we have k, 7 minus 5 is 2, so k squared. And then we have m, 10 minus 3 is 7. And then we have p over p. So if you think about that, that's p to the first over p. Those p's cancel, and I'm left with nothing. Okay, so I have k squared m to the 7th for example 1b. Now, another rule that we need to talk about is the power of a quotient. Okay, so if you take a fraction and you raise it to a power, what you end up doing is you end up raising each piece to that power. Okay, so write that in whatever words you need to in your notes, but the example explains it best. If I have 3/5 to the 4th power, that's the same thing as 3 to the 4th power over 5 to the 4th power, right? Same thing with r and t. If I have r over t to the 5th power, it's r to the 5th power over t to the 5th power. So you just kind of distribute that power to both the numerator and the denominator. So here they want you to practice that, right? So if I distribute this 3, make sure you distribute it to all pieces. So so this is going to be like 3 to the 3rd power, and then we have x to the 4th power, But so going back to last time, if we have x to the 4th power to the 3rd power, remember that we multiply those. So that's the same thing as x to the 12th. And then on the bottom I have 4 to the 3rd power. So you might need a calculator for this, for evaluating these numbers. But 3 to the 3rd power is 3 times 3 times 3, which is 27. X to the 12th. And then we have 4 to the 3rd, which is 4 times 4 times 4, which is 64. There's nothing in common with 27 and 64, so therefore I'm done. All right, so if I go to the next one here, apply that squared to every piece. Okay, so I have 5 squared, then I have x to the 10th power, y to the 2nd power, right, because I multiply those, over 6 to the 2nd power. That's going to be 25x to the 10th, y squared over 36. Nothing is in common with numerator and denominator, so I can't simplify further, and I'm done. Okay, for 2c, let's do the same thing. 2 to the 2nd power is 4. Y squared squared is y to the 4th. Then we have on the bottom 3 squared, which is 9. And then z3, z to the 3rd power, squared is z to the 6th power. And I'm done with that guy because there's nothing in common with numerator and denominator. And let's go on. 4 to the 3rd power here gives me 64. X to the 9th, 3 times 3 is 9. And then on the bottom I have 5 to the 3rd power, which is 125. Y to the 12th. And there's nothing in common with 64 and 125 that I'm aware of, so I am done. Okay, so that's example 2. Now, the last real thing that I need to teach you is the 0 exponent, which I kind of talked about the other day, right? So if you have, the easiest way to see this is like, if you have 2 to the 3rd power, that is equal to 8. If you have 2 to the 2nd power, that is equal to 4. If you have 2 to the 1st power, we know that that is equal to 2. Each time we're dividing by 2, right? So the next time, 2 to the 0th power, if I divide 2 by 2, I get 1. Anything to the 0th power will always have that pattern, so anything to the 0th power is equal to 1. Okay, so that's just a heads up. And then if we go into the negatives, which we will do here soon, we have 2 to the negative 1, that'll be 1 divided by 2. All right, that YouTube clip, if you want to type that into your URL there, you can. I don't think that you need to, but if you want to watch more videos on why this is the case, you can. You could also just Google search that, but I think this kind of gives you a good idea as to why this is the case. For example 3, we have b to the 4th, c squared, d to the 0th, so that's equal to 1, okay, over b squared c. So let's do some simplification. B to the 4th over b squared is just b squared. C squared over c is just c, because it's 2. We have basically 4 minus 2 to give us this 2. 2 minus 1 to give us a 1, so it's technically c to the 1st. And then d is just a 1, so I'm done. So for example 3, you just stop there. You don't want to include that d because d to the 0th is just 1. Now notice for 3b, this is like one of the easiest. If I give something like this to you on a test, this is like, looks like the most complicated thing in the world. It's the easiest problem that I might give you on a test. If this whole thing is taken to the 0th power, remember that anything taken to the 0th power is 1. Okay, so that's all equal to 1. We just use our 0 exponent property. Next we have negative exponents, and again, if we go back to what I said here, a negative exponent just means 1 over. So that's what this is saying here. Is if you have, for instance, 2 to the negative 4, that's the same thing as 1 over 2 to the 4th, which is equal to 1 over 16, right? If I have 1 over j to the negative 4, that's the same thing as j to the positive 4. That's important too. If you have 1 over a negative, it turns that thing positive, and you take that 1 over away. Okay, so it works in the reciprocal as well. So just make sure that you're aware of that one, because we haven't really talked about that piece yet. Okay, so here we go. For 4a, let's work an example together. For this one here, we have v to the negative 3. So what I'm going to do is, I am going to, on my new fraction, since I have v to the negative 3, that's the same thing as 1 over v to the 3rd. So if I'm simplifying this, I don't want any negative exponents. So I'm just going to move that v to the negative 3 down below and turn it positive, because remember, v to the negative 3 equals 1 over v to the third. So I basically, I did 1 over, but we don't include the 1, but I'll keep the 1 there so you don't get confused. For the w's, we have w over w, which is just 1. So I don't worry about the w's, they cancel. And then I have x squared on top. And then on the bottom I have y to the negative 6, but if I want to change that positive, I can just move it up here, right? So that becomes y to the 6th up there. So let's just clean this up a little bit. This is x squared y to the 6th over v to the 3rd power. Okay, so we're messing around with moving negatives. Whenever you have a negative, if you move it to the other side of the fraction bar, it turns positive. Okay, and that's an important part. So for this, for 4b here, let's do this in another color. We have 32 divided by 4. Let's look at that first. 32 divided by 4 is 8. So that's going to be in my numerator because it's like 8 over 1, right? And then I have a to the negative 8. And then you could say that, well, it's over a to the 3rd, so that's minus 3. So that's the same thing as a to the negative 11. Okay, and I'm going to have to move that because it's negative, so I'm going to have to change that later. And then for the b, I have b to the 3rd minus 5. So that's b to the negative 2. Okay, and so I'm going to have to move that one as well. Notice that whenever I subtract, I always have to put that in the numerator, and then we'll fix it later. And then I have c to the negative 4 minus negative 2, right? Because I'm subtracting those exponents. That's c to the negative 4 plus 2, which is negative 2. Okay, so since I have these negative exponents, I need to move them from numerator to denominator to turn them positive. So I have 8 over a to the 11, b squared, c squared. And that is my answer. Okay, so whenever you do your subtraction and you get a negative, you just move it to the denominator and turn it positive. All right, very important. So here we go. For this one, we have 5 over 25. Let's deal with that first. That's the same thing as 1 over 5. Make sure you don't put it the other way around. That fraction, 5 over 25, simplifies to 1/5, right? Then for my j's, I'll keep that j there since there's no other j's. J to the negative 3. Okay, for k's, that's k squared minus negative 4, which is k to the 2 plus 4, which is k to the 6th. So I will not need to be moving that one. And then for the m, I have m to the negative 6 minus negative 2, which is m to the negative 6 plus 2, which is negative 4, right? So m to the negative 4. So now what I'm going to do is anything that's negative, I'm going to move down. Anything that's positive, I'm just going to keep there. Okay, so that's kind of the strategy. So the k to the 6th will stay. Technically there's a 1 there, but we don't have to worry about that. And then we have 5, j to the 3rd, m to the 4th. We can move those guys down there and turn them positive, and we are good to go. All right, guys, that's it for today. We'll get some more practice with this in class. I'm sure there'll be some questions with this, but refer back to this video, especially as we get closer to the test, and refer back to the notes that you hopefully took while you were watching. All right, guys, we'll catch you guys next time.